I'm talking about indices today. What do you understand by indices? Indices are numbers that possess 6 index and base. So, what you need to understand, this is A. This A, we call it base. The M, we do write it in small letter. We call it index or power. So that is the M. So the M is a base. And the N, it is the index or power. So, you must understand this term. And you must be able to interpret the A and N before we can go further in indices. So, there's something common that we need to know about indices. We call it the rules of indices or laws of indices. So, I will not repeat all this any longer because M is index or power, and A is base. This is what indices is based on. So now what talks about laws of indices. In the laws of indices, as I've said earlier, let's have the first law. For example, we have x raised to power A times x raised to power B. X represents the base, as I've explained earlier. A represents the index or the power. The same thing applicable to the second one. X represents the base and B represents the power or index. In this first law, what are you now going to do? You will select only one base, which is X, because it is a multiplication. Now, since it is multiplication, the index will now add together to be A plus B because it's a multiplication. So that is why we have A plus B. So let's have the second one in the laws of indices. Let's have x raised to power A divided by x raised to power B is equal to, now the fact, as I've said earlier, that you will select only one base, which is x. So when you select only one base, because it is a division, you're now going to take that A minus B to give you A minus B. That is the second law. We need to understand this law before we solve any problem. That is how it will give an authority in solving any question. Without seeing the answer, you will know that you are right because you are following the rules. Number 3, if you are given any number raised to power 0, the number must give you 1. Any number raised to power 0, the number will give you 1, provided that x is not equal to 0. So, number 4, if x raised to power minus a, the minus of the index, what will give you is 1 over x raised to power a. So, it has turned to fraction. So, as we reach to this, the law is still many than this. It does not stop in 4. But I want to solve an example relating to these 4 that I just mentioned. So therefore, let me have an example. Now, for example, you were told to simplify a value like 10 squared times 10 raised to power 3. From the law I said earlier, since mathematics requires that you must be able to hold a fact. That's how we call it allows you to have an authority in solving the question. So you will select only one base, which is 10. Since it is multiplication, the index or the power will be added. That is the first law, making 10 raised to power 5. That is just the answer. Now, let's have another related example. Let's call this example 1 or anyhow in any form. For example, the question says you should solve 22n raised to power 7 divided by 2n raised to power 3. In solving this, her mind said that let's rewrite to have 22n raised to power 7 divided by 2n raised to power 3. So this will cancel this. It will give you 11. Now, the division is you select only one n because it will be n raised to power 7 minus 3 because it's n raised to power 7 divided by n raised to power 3, which is n raised to power 4. But alternatively, let me have in another form. In solving this, recall that 22 raised to power 7 over 2n raised to power 3 can be written as 2 times 11 times n times n times n times n times n times n times n. So you rewrite it in in 7 times. So 2 times n times n times n. So the reason why we can't be using this form to solve it is sometimes the numbers of the power may be an high number, so it may be difficult to be writing it one by one. That is why we want to be using the law. But in a way to cross-check our answer easily, these two, we cancel these two. 1, 2, 3. So the remaining one will be 1, 2, 3, 4. So it will be, the final answer will be 11n raised to power 4. That is all. So, how are we able to explain? Let's call this example 1, maybe example 2. Let's have like example 3. So that's, I've been able to explain the first law, the second law. So, let me have something related like somebody said 19 raised to power 0. The answer must give you 1. Any number raised to power 0 must give you 1. So let's have another example like D. Maybe we have 5 raised to power minus 2. As I've explained earlier that any moment a base number raised to power a minus of an index, you will write it in form of 1 over 5 squared, which is equal to 1 over 5 times 5, which is equal to 1 over 25. That is all. So, meaning that 1 over 25. So, I'm using the law, the little one that you are able to have explained, I'm using it, I'm bringing out the example, so you're able to get it clean and clear. So, that is 5 raised to power minus 2. The minus will turn to 1. 1 will be in numerator, and this will be in denominator, 5 squared, and 5 squared is 5 times 5. So let's take go further for better example, so we're able to know that solving this will give you better explanation of the laws of indices. Let's have another example like somebody said 2 raised to power 3 times 1 over 6 whole raised to power minus 1. In writing this, 2 raised to power 3 can be written as 8 times, as I've said earlier, the minus 1. The minus on its own is 1 over 1 over 6. In writing this to be 8 times, now 1 over, it will be 1 divided by 1 over 6. That is just the meaning. Let's rewrite 8 times 1. Let's change this division to times. Know this law today. as you are now, if you don't know it before, anytime you are changing the division sign to multiplication sign, it will the value will reciprocate. So if you change it to times, so it is 1 over 6, it will not change to 6 over 1, which is equal to 8 times 6. So the final answer gives us 48. How do you get 48? It is because we follow the laws. We follow the rules. The moment you're able to follow the rules and the law, you will get it clean and clear without even checking the answer anywhere. In an exam, you will have the authority to get the answer. Let's have another example, like r times r raised to power 0 times r raised to power minus 5. I will rewrite this for you. You have to note something here. The r that is here, it is r raised to power 1. R raised to power 1 times r raised to power 0 times r raised to power minus 5. As I've said earlier, if you study this expression, what is common there, it is the base, and the base is r. You now say that is equal to r onto 1 plus 0 plus minus 5, which will give us r onto 1 minus 5. It will be r onto minus 4, which is 1 over r raised to power 4. That is all. Just straight, it is r just raised to power 1 over r raised to power 4. So with the stage that I reach now, I will give a classwork. Now, you are going to solve this classwork and submit it to comment section. Just type me the answer. So the first one is this. The first classwork is 10 raised to power 5 times 10 raised to power 4 to 5y times 4y raised to power 4. Number 3, a raised to power 3 times a raised to power 0. Number 4, 4 raised to power minus 3. Number 5, 9a raised to power minus 5 times 4a raised to power 6. Number 6, 6 times z raised to power 0. So please, I want you to help me to solve these 6 questions and tell me what your values of your answers, and let me know where we can able to come in. So any challenges that you face, type it in the comment section. I will now know the next video that I'm going to do, so for you to get the exact value, so in case you don't get it better. So as I've said earlier, that the law still proceeds. The law does not stop where exactly I stopped the other time. So we continue. This is another law of indices. We call it product of indices. How? You were given a value, a base value x, an index of a, at the same time raised to power b. So what you are going to give out here is that the base, these are the indices, you just multiply it together. Even though it is raised to power more than 2 or 3. For example, we have s raised to power a raised to power b raised to power c. The value will be s raised to power a times b times c. That's all. So, for example, we were given a value like s squared raised to power 3. So the answer will be s raised to power 2 times 3, which is equal to s raised to power 6. Another value, maybe somebody give you y raised to power 4 at the same time raised to power 2, it will be equal to y raised to power 4 times 2, which is equal to y raised to power 8. So this will give you y raised to power 8. So maybe we have another value like z raised to power 3 at the same time raised to power 5 is equal to z onto 3 times 5, which is equal to z raised to power 15. So this is how, so as it is now, what I just used to explain, don't mind, I will also give a classwork on it, so you're able to practice this exact value. So classwork, so help me to practice this. 1, a raised to power 3 is the value. 2, b squared raised to power 4. 3, 2 raised to power minus 3 all squared. 4, 3 raised to power minus 2 all raised to power minus 2. 5, you stop here. E raised to power 2 at the same time raised to power 3. So you help me to solve this, and in the comment section you give out the solutions. You can share you write it on the paper, you snap it and share it to the comment section. I will see it even in my Facebook page also, but it is advisable to be in YouTube, so I will be able to correct it immediately and do another video relating to it. Now this example is phase 1 example. Now I want to go to another phase of the example that's a little bit deeper than this. So let's have, for example, we want to solve a question like, you open a bracket minus 3 d raised to power 3 all squared let me rewrite minus 3 d raised to power 3 whole squared. So you open a bracket minus 3 d raised to power 3, you close the bracket all squared. I want you to understand one fact, that math, it is the most simplest subject in the whole world. But what to make you to know it is this: you have to consider every sign given to the questions. You discover that we were given a bracket now, and the bracket is closed, meaning that it's telling us that minus 3 squared dot, let's say, times 3 raised to power 3 all squared. So now, telling us that the minus 3 is raised to power 2, and d raised to power 3 is also raised to power 2, so the 2 is common. You can also use this logic to solve a tedious question later. So now, and what do you understand by minus 3 squared? It means minus 3 times minus 3 times, you apply the law here. Recall, minus 3 times minus 3 will give you plus. 3 times 3 will give you 9. Now, d raised to power 6. Do you believe this is just the answer? As simple as this. Now, for example, another question I'm given like in this form. Minus 3, bracket open, d raised to power 3 all squared. Now, my followers, I want you to understand the fact that this bracket, it only affects d. It does not affect 3. So, it will now be minus 3 times d 3 times 2. And the final answer will give you minus 3 d raised to power 6. Final answer, nothing than that. So these are the logical way in solving mathematics. You have to follow the rules and the bracket and the signs. If you follow the signs, you will get the answer correctly. I will try to solve just one example before I give a classwork on these areas. You must, if you want to know this thing I'm doing, please do the classwork. The moment you're only watching this video without doing the classwork, there's tendency to forget it a little bit unless you watch the video again and again. But the only thing that will make you to know it better is to do the class work. So before the class work, let me give you another example that's relating to this. Now, for example, somebody give you a question like this, they open a bracket, minus 4 g raised to power 5 or raised to power 3. As I've said earlier, you can solve this in two forms. Let me use one form like you said, you open a bracket, minus 4g raised to power 5 times minus 4g raised to power 5 times minus 4g raised to power 5. Let me write it. Said minus 4g raised to power 5 times minus 4g raised to power 5 times minus 4g raised to power 5. You can use this literary method. Minus times minus times minus. Because it's odd, you give you minus. 4 times 4 times 4, 64. G raised to power 5, you need to occur in 3 times. G onto 5 times 3. So the answer will give you minus 64 G raised to power 15. Now, but to make it in a quick way, if we have a question like this, G raised to power 5 or raised to power 3, you will just write it in the way that minus 4 raised to power 3 times G raised to power 5 or raised to power 3. So this one will give you minus 4 raised to power 3 will give you minus 64. 5 times 3 will give you G raised to power 15. That's all. So this is how you're able to solve this question without any singular problem. So now I will now give a classwork. The classwork based on this specific example that I just solved. Please, I want you to do it. We have a classwork. And let's 3m raised to power 4, bracket open, bracket close, squared. Let's have 2, 4 v raised to power 3 squared. We have 3 minus c raised to power 3 all squared. 4 s squared 1 raised to power 3. Let's have like 5 here minus c squared times c raised to power 4 onto minus c raised to power 5. Let's have also this minus open a bracket d squared close the bracket raised to power 3 onto d raised to power 4 times minus D. So please, I want you to help me to solve this as the classwork. Try to do it. Take your time to do the classwork. So to make it to get the better secret of indices. So let's also go further. This is a fractional indices. You must understand how to manipulate these two terms. Let me explain it one by one. This x raised to power 1 over a. This can be written as a the root of x. Now, the x raised to power a over b means that it is the b that is the denominator. So, this is not the way I will write it. The a will be around here, yes. So, you write this in form of the b root x whole raised to power a. This is just the meaning of this formula. This is how to use it. B root this and other. We have two forms. So now, let's have an example based on this. We have an example based on these two laws. So let's start. So now, for example, we're given a 9 raised to power 1 over 2. According to the law, anytime you have root 9, 2 is here, but 2, it used to be silent because it is 2. If it is 3, you will write it. It must be greater than 2 before you can write it. So, the root of 9 is plus or minus 3. What do you understand by plus or minus 3? If you have minus 3 times minus 3, it will give you plus 9. If you have plus 3 times plus 3, it will also give you plus 9. So, minus 3 times minus give you plus 9. So, that is all. For example, we also give a value like 8 raised to power 1 over 3. You can rewrite in form of the 3 cube root 8. So, and the cube root of 8, we all know, is 2. For example, we also have a question like minus 2 raised to power 3. So what you do here, you back to the law. Because it has a minus, it will make it to be like a fraction, 2 raised to power 3. Can you see? So, it is because of the minus that now change it to have 1 over the cube root of 8 all square, which is 1 over the cube root of 8 is 2. That is 2 square. So the final answer here is 1 over 4. So it is just 1 over 4. So I will also give you a class work relating to this example. So to make it to know it better and get it clearly. So let's also have another example like somebody said 4 raised to power 1 over 6 times 4 raised to power 1 over 3. You now back to the first law. In the first law, you said, since they have the same base, you select only one base. Because it is a multiplication, you add the indices. 1 over 6 plus 1 over 3. So what do you do from here? In adding this, it will give you 4. The LCM is 6. So 6 in 6, 1. Plus 3 in 6, 2. So it will give you 4 raised to power 3 over 6. Which is equal to 4 raised to power 1 over 2. So if it is 4 raised to power 1 over 2, back to it, it will now be the root of 4, which is plus or minus 2. That's all. That is all. That is just the answer. So, let's also have another example like, maybe somebody give you a question like, He said 16. The reason I'm solving much example is because I want you to get the better knowledge of any questions of indices, any question so far. Now, a question is in this form. So if a question is, it says 16 over 81, all raised to power minus 3 over 4. How do you do this? The first thing you do is this. You said the minus will give you 1 over 16 over 81, all raised to power 3 over 4. So it has now come to positive now. Now, therefore, since the 4, you now say that you now give the both. He said 1 over the cube root, the fourth root, you can call it the 4 root 81 over 16, sorry. 16 over 81 all raised to power 3. So what do you do here? It means that what are the numbers that you are going to multiply in 4 times that will give you 16, and the number that you're going to multiply in 4 times that will give you 81. So in 4 times is 2 times 2 times 2 times 2. 2 in 4 places will give you 16, and 3 in 4 places will give you 81. So therefore, let's continue. We have, so it will now give you that 1 over that is 2 over 3 all raised to power 3. That is, since it occurs in 4 times, so it is plus or minus, plus or minus. So we have to leave down first. We have 1 over plus or minus 8, because to scale this, plus or minus 27. But let's still leave plus or minus now. We have something like 1 divided by 8 over 27. It's equal to 1 times 27 over 8. So the final answer here will be give you plus or minus 27 over 8. So that is just the answer for this. So we still have to solve some tedious question, but before that, I also want to give you a classwork relating to this, which I want you to help me to solve. So let me write the classwork now. So number 1, we have 27 raised to power 1 over 3. Number 2, square root of 1 number 1 over 16. Number 3, 1 over 9 raised to power minus 1. Number 4, 125 raised to power minus 2 over 3. Let's have like number 5, 8 over 27 all raised to power minus 2 over 3. Number 6, 3 raised to power n minus 1 times 2 raised to power 1 minus n. So please, You solve this. You solve this. You just have to follow the rules that I just explained to solve this. So we still go further to solve some example, and the example also has its own classwork. So that is why you need to practice all this classwork, so it will make you to proceed better. So let's have another example. For example, we were given a question like this. Let me have like 2 whole number 1/4 all raised to power 1 whole number 1/2. We are to solve this question. It has been arranged already. We have 2 whole number 1/4 all raised to power 1 whole number 1/2. So the first thing you do, you rearrange, you turn it to improper fraction, which is 4 times 2, it gives us 8. 8 plus 1 gives us 9. 9/4. The 9/4, 1 times 2, 2 times 1, 2, plus 1, it gives us 3/2. 3/2. So what do you do here? You know that it is 2 that come down in the denominator. It will now rewrite as square root of 9/4 all raised to power 3. So the square root of it will give you plus or minus 3/2 all raised to power 3. That's just the meaning. So by the time you now expand, you have plus or minus 27/8. So that is just the answer as the question it is. The reason why I'm solving it stage by stage and the classwork, so you will know how to solve. If you're able to see this, there is no question in the world that you will not be unable to solve. Let's also have another example, like maybe like somebody said 8/50 all raised to power minus 1/2. So now, I would like to do something here. If you study 50, it's not a perfect square or perfect cube number. But let's try to reduce 8 and 50. This thing can be written as 4/25 all raised to power minus 1/2. So if it is that, it means that you cannot write 1/4/25 all raised to power 1/2. So therefore, it means that since it's raised to power 1/2, let's find the square root. So you have 1/4/25, which is 1/2 divided by 5. Since it is a reciprocal, it is 1 divided by 2/5. So to change to 1 times 5/2. So the final answer will now be plus or minus 5/2, or plus or minus 2 whole number 1/2. That is all. So as big as this question is, the first thing I reason about, it is I reduce the 8 and 50. So when I reduce the 8 and 50, it gives me 4 and 25. So that is just the logic so far. So that is how we do. So I will also still stuff another questions that will make us to get it better. To get it. So now let's have For example, we have a question like square root of 72 a raised to power 3 b raised to power minus 2 divided by 2 raised to power 5 b raised to power minus 6. Now, being the square root so far, the first thing you do is this. The square root of 2 divided by 72, we have 36, times this is A. You select 1A. The 3 is the one that is up, minus 5, times B raised to power minus 2. This is division, minus 6. Try to understand me better. I use these two to divide 72. It gives us 36. The A, they have the same base from the second laws of indices. You select only one base to be A. Therefore, you now try to 3 minus 5. This is it. The B also, you said minus 2 minus. So, you now rewrite in another form like 36 times A raised to power minus 2. So 36 times A raised to power minus 2 times B raised to power minus 2 plus 6. So which is equal to the square root of 36 A raised to power minus 2 B raised to power 4. But recall, in this law, anytime we have square root, it will be 36 A raised to power minus 2 B raised to power 4 all raised to power half. As I've said, that anytime you have square root, the square root is also can be written as raised to power half. Let's start now. To have root 36, we're going to have, don't let me write in that form. Don't let me write in this form. You said 36 raised to power half dot A raised to power minus 2 all raised to power half dot B raised to power 4 all raised to power half. You see that the half affects the whole value. Now, since it affects the whole value, you now say, and 36 raised to power half can be written as root 36 times. You're able to see that this will turn to from times 1 over 2 times, you see that B raised to power 4. B raised to power 4 times 1 over 2. So this will cancel this. Root 36 will give you plus or minus 6 times A raised to power 1 minus 1, sorry, there's minus, times this will cancel this, B raised to power 2. Now recall that A raised to power minus n or minus 1 will be 1 over A. Therefore, plus or minus 6 times 1 over A times B squared will now be plus or minus 6B squared over A. You try to watch this video again and again, you gain this logic easily. As it is so very simple. I want you, exactly as you just finish watching this video in this stage, pause it and do this classwork. I'm giving out this classwork. I don't want you to miss anything so far. Now let me do this classwork. I don't want you to miss at all. So the first one is 75. 75 A squared B raised to power minus 2 over 5A raised to power 3B minus 3 Let's number 2. We have 18 over 32 all raised to power minus 3 over 2. Let's have another questions. We have 2x raised to power 1 over 2 times 2x raised to power 3 or raised to power 3 over 2. So please, I'll be happy if you can help me to solve this in the YouTube comment section. You're able to tell me the exact value. So let's just make it to be 5. It is highly interesting when we solve a question like this. 16a raised to power minus 12. So please, let me spell out the question again. 75a squared b raised to power minus 2 divided by 5a raised to power 3 b raised to power minus 3. Number 2, 18 over 6 bracket open bracket close raised to power minus 3 over 2. 3, 2x bracket open and close raised to power half times 2x raised to power 3 bracket open and close 3 raised to power 3 over 2, and 4 0.125 raised to power minus 1 over 3, and 4 root 16a raised to power minus 12. So please, how we want you to help me to solve this. As this part now, we are now, after this, you have solved this, we are going to another sections of indices, which we call indicical equation. Don't try to forward this video. If what we are doing is meaningful to you, please subscribe to this channel. I'm giving out all this logic, the secret of maths as free. What I want you to do, please help me to subscribe to the channel. This is the only way you can pay back us using my data and another. Please help us to press subscribe. This will help me to know that you are watching the video and you are gaining. This is what I like doing, and I want you to help me to press subscribe. So in the next sections of this video, which will continue now, it is another form which we call indicical equations. How we solve indices in another logical forms, in very logical forms. This is another forms of indices. We call it indicical equation. If a raised to power n is equal to a raised to power n, you observe that these are same. Since a is the same thing, since the base are equal, therefore n is equal to n. Another form. If a raised to power n is equal to b raised to power n, you discover that the index are same. Meaning that, therefore, a is equal to b. Let me re-explain. We have only just two forms for indicical equation. If the base are equal, it means the index must be equal. If another form, if the index are equal, it means the base must be equal. So any forms of the equation that comes to your side, make sure you know how to manipulate it and try to get the answer. So let's start solving the answer now. So start solving. The question is given like this. He said 8 raised to power x is equal to 32. If a number is given in this form, you understand that 8 on its own is 2 raised to power 3. 32 on its own is 2 raised to power 5. Now, let's rewrite this 8 to have 2 raised to power 3 or raised to power x. 32 is 2 raised to power 5. You should remember the law, that's the powers of the law of indices, that since they occur like this, you multiply them to have 3x, which is equal to 2 raised to power 5. Therefore, record that this now the same. The base now the same. It means that 3x is equal to 5. So, divide both sides by 3, our x will be 5 over 3. That's all. So, this is what I mean by indicical equation. That since you observe what the value is, the next thing for you to do is, when the bases are equal, it means the index must also equal. Let's have a logical example again. A little logical, like having 2a raised to power minus 1 over 2 is equal to minus 14. Let's divide both sides by, let's reduce it by 2. We have minus 14 over 2, which is equal to minus 7, meaning that minus half is equal to minus 7. Now, in a way to make a as a subject of the formula here, just above to back, let's square the both sides. Square the both side of the equation. So, we have a raised to power minus half, less squared, is equal to minus 7 squared. So, if you squared this, it will give something like a raised to power minus 1 over 2 times 2 is equal to minus 7 squared, as from here to give you 49 plus 49 plus 49. So this will cancel this. A raised to power minus 1 is equal to 49. Mean that 1 over a is equal to 49 over 1. Let's cross multiply. 1 is equal to 49a. So if you have 49a is equal to 1, mean that a is equal to 1 over 49. So that's all, which is all, or 1 over 7 to the power 2. That's all. So what I just try to do here is the logical. You square, sometimes you find the square root, sometimes you square. So you just have to use some logical terms to get a value of the answer. Let's have another reasonable example. Maybe we can be able to gain from it. Like a question is given like x raised to power 1 over 3 is equal to 4. Let's find the cube roots, the cube of the both sides. Find the cube of the both sides. So when you get the cube of the both sides, so we have x to the power 1 over 3 all raised to the power 3 is equal to 4 raised to the power 3. So this will be x to the power 1 over 3 times 3 is equal to 64. So x here is equal to 64. That's all. Nothing else to change from that place. Is equal to 54. So you just have to, let's have another example. I want you to get some facts about this. I will solve as much as possible so you can gain better in this the part of the indices that we have. For example, we have this is easiest one so far. 4 raised to power c minus 1 is equal to 64. You know that 64 can be written as 4 raised to the power 3. So 4 raised to the power c minus 1 is equal to 4 raised to the power 3. Recall that 4, the base of the both sides are equal. So therefore, c minus 1 is equal to 3. Therefore, c is equal to 3 plus 1, which is equal to 4. So that is just how to solve this. So many questions like this, you just have to learn how to manipulate and get the exact values of indices. So from the beginning, which we're able to explain better about the indices, the law. Before I stop and give you a classwork in this section, I want you to remind yourself about what you have been able to discuss earlier about. So this is where, as at back, the first stage of indices, this is where it is taught. The first stage. What I mean by first stage is the elementary stage of indices right now. This is where they stop. So we see let me have another example. Let's have an example like, let's have like 2x raised to the power 3 is equal to 54. So naturally what you do is you try to reduce sometimes. Reduce the both side by 2. So when we do this, we have 2x to the power 3 over 2 is equal to 54 over. So anytime you said reduce means you can divide. So 2 we cancel 2 here, we have s to the power 3 is equal to 27. Recall from the factorial of 27 we have 3 times 3 times 3. So 27 can be written as can be written as 3 raised to the power 3. So mean that s raised to the power 3 is equal to 3 raised to the power 3. So I don't need to explain more. But most important thing is, this is what I'm going to. Now the index are now the same. They are now same. So index is 3 and 3. So therefore, x is equal to 3. That is all. So please, I would not like to give you a classwork in the last sections. Indices is still proceed to some parts which you are still. That is why you must subscribe to this channel. So anytime I'm releasing, I'll try to release some videos that will deal about question and answer, maybe for indices, for some questions, for some topics like that. So when I release this, that is why I now put the indices of SS3. It is where we now talk about a little advanced indices, and the indices in further mathematics is quite different to this. So, but stay tuned to this channel. Subscribe to the channel so you'll be able to gain better. So let me write the classwork for the last stage of. So let me write the classwork. The first one is n raised to the power minus 2 over 3 is equal to 9. 2r minus 3 is equal to minus 16. Number 3, 5x is equal to 25. Number 4, a raised to the power minus 2 is equal to 9. Number 5, a raised to the power minus 1 is equal to 2. So let's stop in this 5. Let me spell it out again. We have n raised to power minus 2 divided by 3 is equal to 9. The second one, 2r. The r, it is one that raised to power minus 3, is equal to minus 16. And number 3, 5 raised to power x is equal to 25. And 4, a raised to power minus 2 is equal to 9. Number 5, a raised to power minus 1 is equal to 2. So please, you will solve this question and tell me the answer in the comment section. In the YouTube section, you just type the answer to the channel. And don't forget to subscribe. If you see that what you are doing in this lecture, you are gaining, if you are gaining from this lecture, so me too to have more courage, help me to click subscribe to the channel. It is highly important, so to give me kind of motivation. This is the only motivation I will have. I'm only doing what I love to do, and I believe you are here to gain. So once again, you are welcome to this channel. Please don't forget to subscribe. Thanks for watching.